So here's a quick example of how to solve a problem using Newton's second law of motion. The goal of this problem is to apply Newton's second law in one dimension, together with the equations of kinematics. The problem states, an airboat with a mass of 3.50 times 10 to the 2 kilograms, including the passenger, has an engine that produces a net horizontal force of 7.70 times 10 to the 2 newtons, after accounting for forces of resistance. Part A asks to find the acceleration of the airboat. First up, we need to know what Newton's second law of motion is. Newton's second law of motion is net force equals mass m times acceleration a. For this problem, we need to solve for acceleration. What we do for part A is use the net force equals mass times acceleration formula and divide mass from both sides. As a result, your acceleration equation is net force divided by mass. We know that our net force is 7.70 times 10 to the 2 newtons, and our mass is 3.50 times 10 to the 2 kilograms. Your resulting acceleration is 2.20 meters per second squared. Part B states, starting from rest, how long does it take the airboat to reach a speed of 12 meters per second? Part B is asking us to solve for time. For this, we need to use the equation final velocity equals acceleration times time plus initial velocity. First, we need to subtract initial velocity from both sides. Next, we divide acceleration from both sides. And the resultant equation for time is final velocity minus initial velocity over acceleration. Time equals, our final velocity is 12.0 meters per second minus 0 meters per second because the object starts from rest, divided by the acceleration we solved for, 2.20 meters per second squared. Your final answer is 5.45 seconds. Part C asks us, after reaching that speed, the pilot turns off the engine and drifts to a stop over a distance of 50.0 meters. Find the resistance force, assuming it's constant. First, we need to solve for acceleration. To solve for acceleration, we use the formula final velocity squared minus initial velocity squared equals 2, which is a constant, times acceleration times delta x. So we're solving for acceleration here. We plug in our known values. Since the object ends at rest, reaches a stop, our final velocity is now 0 meters per second. And we square each of our velocities. Our initial velocity, since the object was initially moving, is 12 meters per second. And we square that as well. We set that equal to 2, the constant, a, the value we're solving for, and delta x, which is the change in direction. Our delta x is 50.0 meters. First, we can cancel out the final velocity because it's 0. Next, we take the 12 meters per second and and we square it, set that equal to 2 times 50 times acceleration. Negative 12 squared is negative 144. 2 times 50 is 100. We divided 100 from both sides, and your acceleration is negative 1.44 meters per second squared. But we're not done here. We need to solve for the force in resistance. The resistance force equals mass times acceleration. We know our mass is 3.5 times 10 to the 2 kilograms. And we know that our acceleration is now negative 1.44 meters per second squared. Your final answer is negative 504 newtons. Now we go back to each part of this problem and circle our final answers. That's all for now. Thank you for watching and listening.